On the internet, DNS is the way that things find other things, and your Kubernetes cluster is no different. But did you know there's a cool little tool and utility that you can install on your cluster that will map out how services talk to each other in real time using DNS? If you didn't, check out this video. Let's get straight to it. So I'll start by creating a brand new cluster. Next, I'm going to install the Otterize network mapper. And let's just wait for those pods to spin up in the Otterize system namespace. So while you're waiting for those pods to spin up, go on ahead over to the Otterize CLI GitHub and download the CLI binary. We're going to need that to actually interact with the network map, because what we're going to do is extract that network map from the cluster, and then we'll write some Python to actually visualize this on our machine as a nice PNG. Good, so by this point both of the pods, the network mapper and the network sniffer, are running, and I've just put my Otterize CLI into a tools directory, but you can just check that it's actually running and available. Next, it's time to deploy their sample application. It's really simple, this one. You've just got two clients, client 1 and client 2, and both of those are going to talk to the server. So let's go ahead and deploy that. Okay, and once all three of those pods are running, if I clear that down, we should be able to now start generating that network map, because this happens in real time. So let's use the Otterize CLI that you installed previously, the network mapper command, and export the traffic or the map for that particular namespace. And let's see what it gives us. What it gives us are two YAML documents of type client intents, and the way to read this is you have a client as a workload that talks to a target, which is a server. And then there's a second one, the second client talks to the server as well. And that's it. That's in real time. We've done nothing else. It's just sniffing the DNS traffic, and it has built, it knows that these things are talking and connecting to each other. But let's take this a step further and actually visualize this in a nice way. So what we can do is output that data as a YAML file. So I'm going to rerun that command and pipe it to data.yaml. And you'll see, simple, it's just spat it out and saved it as a YAML file. And now we can start the little Python script that I created. All of the links to this, if you want to try this out, will be in GitHub as per usual. Let's just activate the environment. Yep, and whoops. Install all of the requirements, and hopefully, if this works, we should be able to run python app.py and see that client calls the server and client 2 calls the server. And all we've done here, all I've really done, is load in that YAML file, parse that YAML file, and see who is talking to who. Let's try this with a little bit more of a complex example. This time I'm going to spin up the OpenTelemetry demo app, no instrumentation whatsoever, and I'm just going to let the network mapper run and see what it can figure out about the OpenTelemetry demo app. And then I'm going to cross-reference that to the official architecture diagram from the OpenTelemetry demo app. Let's get to it. One thing to mention about the OpenTelemetry demo app, I have, because of resources on this machine, I've turned it down a little bit. I've turned some things off. So I've still got the ad service enabled, but I've messed with the requests. I've disabled the currency and the email service. Kafka's still running, the load generator is still running, and I've turned off all of the other observability features like Grafana and Jaeger and OpenSearch and Prometheus, and even the OpenTelemetry collector. So it is a slightly customized version, but it should give us the picture. So I'll go ahead and install all of that. And through the magic of video, I'm going to come back when everything is running. Okay, most things are running. Let's just check. The ad service was crash loop back offing, but I've fixed that. And my recommendation service is still pending, but I'm gonna assume, well, I'd not assume, it is because I've run out of resources. But this is good enough to give us at least a baseline of what I was talking about. So those services, the ones that are running, should be talking to each other now. Let's go ahead and regenerate the network map. So I'll just delete this one. I will regenerate the network map. And let's have a look. Yeah, accounting is talking to Kafka and lots and lots and lots of other stuff. So now let's run it back through the application, the little Python script that I wrote. And let's see what we get. The moment of truth. Okay. What have we got? We've got the front-end proxy. Let's try and zoom in. The front-end proxy calling the front-end. The front-end calling checkout. The front-end calling cart. Checkout calling cart. So let's have a quick look at the OpenTelemetry architecture to see how close we've got. Demo architecture. Okay, front-end proxy calls front-end calls checkout, checkout calls Kafka. Okay, let's see if we can get there. So, front-end proxy calls front-end calls checkout, checkout calls the queue, Kafka. Down here. Yep. I'm not going to go through the whole thing, but you get the point. This has mapped our namespace and the traffic flowing between the services. Now, two things to point out. One, it is a real-time map. It's constantly updated. So when I ran that export to the YAML file, that was a snapshot in time. So yes, the payment services sat on its own. That might be because I've turned some other services off, or it just wasn't being communicated with at that point. So you'll have to figure out a way to run this periodically to get a new map each time. The second thing to point out, well, does this do away with OpenTelemetry? Does this do away with distributed tracing and logs? No, because this is all you get. You get a very outside-in, high-level view of the traffic that's going between the services. OpenTelemetry, and particularly distributed tracing, get you inside each of these. So they get you into the endpoints and into the actual code that's running. So this is not a replacement for OpenTelemetry, but it is a really nice lightweight way to start mapping out your cluster. I hope this was useful. The links to the demo application that I wrote, the Python app, and obviously the Otterize network mapper are all in the video description below. Hope you found this useful. Until next time, see you. Bye.